Imagine traveling to another star system. Not in thousands of years, but in hours. Not science fiction, not a movie, but a real possibility. In labs across the globe, a quiet revolution is unfolding. For the first time, scientists are on the brink of building a warp drive, one that could allow us to break the ultimate speed limit, the speed of light, and the most mind-bending part. The technology might arrive not centuries from now, but within our lifetimes. This is how it could happen. For over a century, the speed of light, 299,792,458 meters per second, has been the ultimate cosmic speed limit. Einstein's theory of relativity makes one thing clear: nothing with mass can move faster than light. Doing so would require infinite energy, and infinite energy is impossible, or so we thought. But what if we don't move through space at all? What if space moves around us? That's the revolutionary idea behind warp drives. A concept first imagined in science fiction, and now developed in serious scientific labs. Let's be honest, without faster-than-light travel, we're stuck. The nearest star system, Proxima Centauri, is 4.2 light-years away. At today's speeds, even our fastest spacecraft, the Parker Solar Probe, would take over 70,000 years to get there. Colonizing Mars, a temporary fix, because Earth won't last forever. From climate change to asteroid threats, our long-term survival depends on going interstellar. Faster-than-light travel isn't just a dream anymore. It's becoming a necessity. Enter Miguel Alcubierre. In 1994, the Mexican physicist published a paper that shook the scientific world. He proposed a warp bubble, a region of space-time that contracts in front of a spacecraft and expands behind it. Inside the bubble, the ship doesn't move. Instead, space itself moves, carrying the ship faster than light without breaking Einstein's rules. There's just one problem. Alcubierre's design required exotic matter with negative energy, a material that may or may not even exist. But recent breakthroughs are changing the game. In 2021, NASA physicist Dr. Harold Sonny White made an astonishing discovery while experimenting with the Casimir effect phenomenon involving quantum vacuum. Energy's team observed structures resembling tiny natural warp bubbles. They were microscopic, but real. And if nature already creates warp bubbles at the nanoscale, why not engineer them on a larger scale? By tweaking the geometry of Alcubierre's design, White reduced the energy requirements of a warp drive from planet-sized to just hundreds of kilograms of negative energy. It was the first practical step toward real-world warp travel. Meanwhile, in Germany, researchers at the University of Potsdam took warp theory into uncharted territory. In 2024, they used computer simulations to analyze how warp bubbles would affect gravitational wave patterns. Why? Because if warp travel is real or has ever been used, signature might be hidden in the data collected by LIGO and other observatories. Imagine detecting not aliens, their mode of transportation. Even better, if we can recognize those patterns, we might replicate them. We wouldn't need to invent warp drives. We'd reverse engineer them from nature, or from civilizations far more advanced than ours. Today, scientists are developing 3 leading models of warp propulsion. Alcubierre drive. The original requires exotic matter, still theoretical. Drive, a refined version using different space geometry, more mathematically stable but still reliant on unknown energy types. White's low-energy warp drive, potentially the most feasible. Rooted in quantum geometry and tested at a nanoscale. Each has its challenges. Risk of space-time collapse, energy instabilities, unknown materials. But every model proves one thing. We're no longer asking if warp drives are possible. We're asking how soon. SpaceX, NASA, private labs. It's no longer science fiction writers leading the charge. It's aerospace engineers, quantum physicists, and propulsion theorists. Some predict we may see working prototypes in the next 10 to 20 years. And when that happens, travel to Alpha Centauri in hours, exploring Earth-like exoplanets in nearby systems, even sending probes across the galaxy in days. Faster-than-light travel wouldn't just revolutionize space exploration. It would redefine our understanding of time, energy, and reality itself. We once looked at the moon and thought it was unreachable. 60 years later, we walked on it. Now, we stare at the stars and wonder if we'll ever get there. But the tools, the theories, and the dreams are aligning. We may be just one breakthrough away from opening a gateway to the cosmos. And if that happens, the stars may no longer be out of reach. They may be our next home. Subscribe now for more videos about warp drives, quantum tech, and the future of space exploration.